Bryan, we have started to record the meeting as well. So thank you very much for joining us today. And you should have...
Thank you, Kara, and thanks for everyone for dialing in this afternoon. So what I'm going to do here is provide a brief overview of the context of connecting science and policy. That is, after all, what we're trying to do here is take the very best science in the Great Lakes Basin and move it to decision-making using a variety of approaches, including high-end technology. So just want to put the project into context at the very beginning, and then get into a little bit of discussion of what is a tipping point so that everybody has an idea about it as we kind of move forward here. So the presentation will have 4 parts to it. I'm going to, again, kind of summarize a little bit of the science of the interface of policy, and then move a little bit into project objectives, just a very, very brief overview, kind of giving you an idea of who's involved, especially from the research end. And then I'm going to cover what is a tipping point using some of the very common conceptual frameworks that have been, I can't believe somebody's falling now. Okay, I just turned the ringer off. And then I'm going to briefly talk about how do scientists detect its tipping point, and how are we doing it in our project, because it's not an easy thing to do. So project is motivated from really the need to think about restoration, sustainability, and a lot of the, I would say, great thinkers of our time right now, including Bill Clark, who's at Harvard, kind of gathered the best thinkers on the planet and outlined what we need to do to better direct science towards what many of us call grand environmental challenges. So he says that, and they say that, you know, look, as a society, we're facing a lot of problems across a variety of scales, from local to global. And really, we need to solve these over the next decade. And to do this, we need to bring together a variety of disciplines and really work closely with stakeholders and decision makers. So this kind of has motivated a lot of people. It's been out in the literature now for about 3 years, and is probably the most highly cited paper right now in environmental science. In this paper, they kind of suggest that one of the things that we need to do is look for what we consider as our safety zone, planetary boundaries. Where do we need to exist? How do we need to live within an ecosystem that can be stressed by human activities? And so we need ways to think about the role of humans and the way in which ecosystems respond to change and respond to our behaviors. And we need to really avoid going over the edge. And so what we need from the standpoint of both the science and from decision making are early warning systems and tools. Systems allow us to know, well, are we approaching a tipping point? And if so, what can we do to avoid that? And so what we've decided to do here is, because this is really new, the concepts of tipping points and thresholds and trying to move this science out to decision makers, is combine what we consider to be relevant outcomes. If you look across all of science, what you see is a focus on what we might consider to be outcomes that are relevant to society, and the need to motivate and to advance our knowledge. And so in the last couple of years, many scientists have moved from really a more pure basic research focus, which is, public view of that from a university standpoint is what we call the exalted science in universities, the ivory tower, and to consider not only just advancing knowledge and science, but also to assist societies. And so The research that we're doing is oftentimes referred to as that falling within Pasteur's quadrant. In other words, we're making advances in both the sciences, but we're trying to deliver that information as soon as we can to decision makers. The progress in environmental science over the last several decades follows this pathway to a point where I think we are really at the point where the science is converging on both decision making and its use. So back in the 1980s, we saw a lot of focus on just developing theories and ideas, but we had no data. In the 1990s, we had a lot of data being generated by federal agencies through the use of satellite technologies. And then in the 2000s, we had a growth and maturation in new models that are becoming better predictors of the future. For example, I think that weather models and climate models in particular have become much more precise over the last 10 years because we've really advanced both data and the science. Many folks now consider the decade that we're in right now as the decade of solutions. The idea here is that we really need to connect science and policy. We need to integrate the disciplines. We need to think about online tools, moving from generating maps to even providing information on handheld mobile devices. So that's where we are right now in terms of science as kind of a discovery process, and really the need to connect the science with policy. So the core principles of our project is to use theory to frame science and policy, and to search for tipping points where they are relevant and where we have high quality data. And we're really bringing to bear, I think, some of the greatest researchers across the Great Lakes Basin. We're employing multiple methods. We're not just using one method, but we're using about a dozen, oftentimes using several methods with the same data set, just to ensure that we have a robust analysis. We're looking at tipping points from a variety of different spatial and temporal scales, as well as governance scales. And we are connecting to stakeholders, groups like this, to help drive its use. We are developing what I would consider a very diverse partnership that spans research, extension, and planners. So utilizing the best infrastructure that society can provide. Leveraging the science and tools to help guide conversations with communities. So we don't want this science and everything else that might be generated from it to be held within the confines of our ivory tower. We certainly want to reach out to communities and get this information out to decision makers. We realize that consensus is not going to be universal, so let's provide the information that is most politically unmotivated in ways in which people can look at it objectively. So the project objectives are to, number one, develop scientifically valid tipping points, help define those boundaries that we need to stay within, incorporate early warning tools into planning platforms for use across the Great Lakes Basin, and the work should be stakeholder-driven, supported by the very best science. And again, we're going to use the technology to interface the science and our big ideas to decision making. The project team is diverse, and you'll recognize many of the players if you've interacted with them across the Great Lakes Basin, and they're highly motivated. We're all interested in doing good, and many of us have been working together for 10, 20 years. So we have folks from just about every state in the Great Lakes Basin, along with Sea Grant specialists that are highly motivated to getting the word out and getting the tools in the hands of the people that can use it. So the burning question might be, what is a tipping point? If one of the projects that I had a master's student, a really bright student that came into my lab several years ago, I gave her the question, well, what's been the history of its use? And I want to know it from the standpoint of social science and medicine and philosophy, And so she dug into literature, spent about 6 months, and really found very little in the literature prior to about the year 2000. So there were quite a few papers and books that were generated under these big concepts of tipping points and thresholds and multiple stable states, many of which we study as even undergraduates now in ecology classes. But it really wasn't until about the year 2000 when Malcolm Gladwell came out with a book that's called Tipping Point, and someone gave it to me the first week it came out, and I tore through it, and I was very, very excited about some of the things that he talked about. Basically it says very small things, very small changes can make big differences. And we all know that from experiences as part of just being part of society. But as an ecologist, I know that to be true as well. We can make very, very small changes. We can stress the environment, and eventually it will change, and it will change in a very dramatic way. And so what we want to do as ecologists is study where those tipping points might be, and then provide that information to decision makers so that we can avoid kind of going over that edge, so to speak. So how can we conceptualize a tipping point? What I've got here for you is very, very general, but I think it might help you because it helps me at least to walk through some of the major concepts. So ecologists often consider an ecosystem existing in one or more states. Oftentimes we're very interested in keeping the good state, the desirable state. And if we go out and we measure a bunch of parameters, we can basically say, well, this plot of land, this watershed, this forest stand is in a good condition and exists in a certain kind of configuration within this, what we call state space. Eventually a disturbance comes along and then might move it to a different position, and it still might be in a fairly good, intact system. And we know that ecosystems are always disturbed. We have hurricanes, we have fires, and so they always come back. And so we're interested in that as a physical property. Well, we also know that ecosystems can exist in bad states. These are called traps. We know these as either pollution traps or poverty traps if you're in the social system. And so what we want to do is make sure that we avoid going into that bad state. Sometimes a big stressor might come through and some kind of big disturbance. It might be something very, very big. It could be a pollution event, or it could be a stressor like a lot of development pressures that might exist across the landscape or in the watershed. And then what it does is it moves it over into the bad state. As it moves from the good state to the bad state, it has to go through this little transition zone. And the transition zone is really key because that's where the tipping point exists. It's a hybrid composition of state A and B, and we've known this for a while. We've known this as ecologists for about 40 years. What we're now coming to realize is that as a location or a watershed goes from a good state to a bad state, we see a lot of variability occurring within all the things that we begin to measure. In other words, an early warning signal exists that is basically increase in variability. So what we want to do is go out and measure the system and begin to look for those early warning signals. In other words, when things start becoming highly variable. So how do you do that? Well, what you do is you begin to look at all the different ecosystems across a very large region and begin to plot out. So if you were to look at something like an indicator, this is kind of a measure of an ecosystem status, and begin to look at it over time and plot out the current state of an ecosystem, we can say, well, this watershed has about 20% agriculture. If we continue to add and expand, that is considered a disturbance to the ecosystem, and it begins to move more up into toward this tipping point. And as we begin to observe the ecosystem, the water quality, for example, the biological community, what we see, what we have evidence of, is a spike in variability. So what we want to do is take that variability, that signal, and begin to look at it across different kinds of ecosystems. The challenge is that we cannot follow a watershed for more than 20 or 50 years. So we just can't sit here and wait for that. Matter of fact, it might be too late. Many of us realize that you don't know that you've surpassed a tipping point at a particular location until you're in the other ecosystem state. So what do? Well, as scientists, we've recognized that one of the things that we can do to think about forecasting and think about the future is to do what we call a space for time substitution. It's basically looking at all the different ecosystems across a region and begin to look at them in kind of very general terms. So how would you do that? So here's the Great Lakes Basin, and we could go through and calculate, for example, the amount of agriculture that would exist in each one of our watersheds. And if we begin to plot these out, what you will see is these trends that begin to emerge. And we've seen this in several different data sets already. We see the spike in variability, and I'm going to use my little arrow here to be able to say that point right there is one that we're identifying and calling a tipping point. It's moving from one state to another. It's moving and then passing and going downhill here in terms of the amount of variance. So let me get rid of this arrow. So what the science team has done over the last couple of years, this has been really bleeding edge science, is to explore a variety of indicators and potential tipping points in different kinds of ecosystems. Hit the wrong button. We've looked at land use, population, roads. Matter of fact, we've taken a lot of indicators that EPA has suggested to us are stressors on ecosystems and begin to look at them within this context of a tipping point, within all of the tools that we've developed. And we've looked at it from a standpoint of watersheds, nearshore zone health, coastal ecosystems, beach health, fish community structure, and abatements. We also have interfaced a lot of these tipping point tools to other kinds of models. One in particular is a land use forecast map that's been developed out of our lab that allows us to look into the future. We project out using a variety of spatial temporal tools and sophisticated algorithms that allow us to kind of project out and consider what would the future look like if we were to go in this same direction that we have been over the last 30 or 40 years. In other words, what's the business as usual forecast look like for the entire Great Lakes Basin in terms of land use, in terms of major stressors that we've identified, urban and ag. We've taken this information and then put it in the context of what we call dashboards. Easy to use, easy to understand little dials that allow us to tell everybody who wants to know where is the current state of their ecosystem, and then given business as usual strategies, like where would we be in 2050, for example, if we were to kind of assume a business as usual strategy. So we've configured a lot of these tools under the hood of something that we call Tipping Point Planner. Many of you are going to become experts at it. And the idea here is to be able to provide these maps and these tools, these asset maps to you all so that you can use them in a community forum and play with what-if sorts of tools and analyses on the basis of some of the underlying science. So All of this work converges into an online decision support system. Jared's going to give an overview of that in 2 presentations. But again, to recap where we're at, the current state of scientific discoveries is focusing on grand challenge questions. And so what we have here, the point I'm trying to make here is that we're not taking science that is 30 years old. We're taking science that's about 6 months old. We're taking science that's really bleeding edge to the scientific community and providing it to you in ways that we hope is easy to understand. Tipping points can help define the zone that we should not cross. So the idea here is to convey to people that what we have is scientific evidence that suggests that ecosystems can go from good to bad. And we have a lot of good data and a lot of good research that suggests that there are points that are critical thresholds. Increase in variance is an early warning signal. It's one that we're using a lot across the project. And I think that many of us are probably aware of this on a daily basis. We know that anything that spikes and becomes erratic is something kind of indicative of change. And so this is not surprising to a lot of ecologists or even social scientists that we could use something like this. But it is an early warning signal. Scientists use really crafty ways, we call it space for time, approaches to identify a tipping point. And we have a lot of very sophisticated models under the hood that you can work with to ask what-if kinds of questions, so you can determine the direction of your community on the basis of business as usual scenarios. And so the idea here, again, is that we have a lot of good science here. We're trying to incorporate this into this online decision support system. And the rest of the presentations here are going to provide you with a lot more detail about every aspect of the project. So certainly want to acknowledge the funding for the project. It's coming from a variety of sources. The primary is the Great Lakes Restoration Initiative, coming out of EPA and NOAA. And of course, I want to give special thanks to the folks down there in the bottom who really did most of the work. I just sit here and just run the slideshow and talk about the slides, but many of the graduate students that are in our labs and postdocs and staff have thought through and worked through. And I'll tell you, it's been a very, very difficult, long process, mostly because we are doing very advanced scientific research here. So that's all I've got.
Okay, thank you very much, Bryan. We